Hi, good day everyone. So today we're going to do vectors and matrices number 10, May, June 2023, right? They said the matrix A and B represents a transformation below. A is represented, this is a matrix that represents an anticlockwise rotation of 90 degrees about the origin O. And B, this is a matrix represents a reflection in the straight line y is equals to minus x. Determine the elements of matrix C which represents an anticlockwise rotation of 90 degrees about origin O followed by the straight line, right? So this is what is going to happen. What is this? Anticlockwise rotation about 90 degrees. This is A, matrix A. And this here, reflection about the straight line, is matrix B. So C is equal to, if we're going backwards, it would be B multiplied by A. So you're multiplying these two. And what is B? 0 minus 1 minus 1, 0. Multiply by A, which is 0 minus 1, 1, 0. Now, when you have to multiply matrices, the first thing that you do is check to see the order of the matrix. The order of the matrix is the number of rows multiplied by the number of columns. What is the number of rows in this first matrix? 1, 2, that is your horizontal. So it is 2 rows multiplied by how many vertical columns we have in this? 1, 2. So it's 2 rows by 2 columns, and this is 2 rows by also 2 columns, right? To make sure that they are conformable to multiplication, we need to check if the number of columns in your first matrix, that's this here, is equal to the number of rows in your second matrix. So you'll see me always put in a little box like this. This is equal, so they are conformable. If those two numbers were different, then they cannot multiply, right? And your resultant matrix, which is Rm, would be the number of rows in your first column, in your first matrix, multiplied by the number of columns in your second matrix. So it's a 2 by 2, right? Now, if you're new to multiplication of matrices, right, 2 by 2 is 4 elements. So it has 2 rows, 1, 2, 1, 2. So 2 rows by 2 columns. So this is row 1 by column 1, row 1 by column 2, row 2 by column 1, and row 2 by column 2. Right? We say E11 would be row 1 by column 1. So it's 0 multiplied by 0 plus negative 1 multiplied by 1. Right? And then E12 is row 1 by column 2. Right? You see I have 1, 2, row 1 by column 2. So it's 0 multiplied by negative 1 plus negative 1 multiplied by 0. Right, and then E21 would be a second row by a first column, so that's negative is equals to negative 1 multiplied by 0 plus 0 multiplied by 1. And then E22 would be your second row by a second column, so it's this is equals to minus 1 by negative 1 plus 0 multiplied by 0. Right? Now, when you can just use a calculator to check it if you don't know it as, if you can't see it. But this is basically 0 plus negative 1 and 0 plus 0. This section is 0 plus 0. And then 0 plus 0 again. And then positive 1 plus 0. So this is going to be equal to negative 1, 0, 0, 1. So this here is matrix C, right? Okay, now they told you describe geometrically the single transformation represented by C. This is something you have to know, right? When you have, let me see, minus 1, 0, 0, 1, that is equal to, I think it is equal to y is equal to x, if I'm not mistaken. No. The reflection on your y-axis, not y is equals to x. This is your reflection on your y-axis. So once you know that negative 1, 0, 0, 1 is a reflection on your y-axis, that's the answer here. Describe geometrically the single transformation represented by C. It is a reflection on your y-axis. And that is it. Right? That's 2 marks for you to remember the matrix and what it stands for. Right? Let's look at this one here, part B. A transformation T is defined by the following 2 by 2 matrix, where T is 1 to K minus 1, where K is a constant. When T maps onto point 2, 3, right? So when this maps onto the point 2, P, it gives you the image. So I'm going to put this as the object and as the image, so object P. So when you multiply that transformation, multiply by P, you'll get image P. Right? So basically what I'm saying is 1 to K minus 1 multiply by, you're going to change 2, 3 to a column matrix. Right? That is 2 on top, 3 at the bottom. Right? This is going to give you 8, 15, and 8, 15 is also transformed as a column matrix. Right? So 8, 15 as a column matrix would be your x values on top, your y values at the bottom. So it'll be 8, 15. Right? So first off, let us see if this makes sense. Can we multiply T by P? So this is a 2 by 2 matrix, and this is 2 rows by 1 column. So can these two multiply? Yes, because the number of columns in your first matrix is equal to the number of rows in your second matrix, and your resultant matrix would be a 2 by 1. And this is 2 rows by 1 column. So we know that it is definitely T by P is equals to P1. So we know that, let's multiply it out, right? So it is going to be your first row by your first column. So it's 1 multiplied by 2 plus 2 multiplied by 3. That is 2 plus 6 is equals to 8. So we see that is correct. And then your second row by your first column, it's K multiplied by 2 plus minus 1 multiplied by 3 is equal to 15. Right? So that's 2K minus 3 is equal to 15. We want to find the value of K. So simply make K the subject of the formula. We carry across minus 3. That's 2K is equals to 15 plus 3. So 2K is equals to 18. You carry across multiply by 2. The opposite of multiply by 2 is divide. So K is equals to 18 divided by 2. So K is equal to 9. Right? Now, okay. Now we're going to go into part C of this question, which is the vectors question, right? The following vectors are defined as below. Wx is 5 minus 1, xy is minus 3, 7, zy is 8 minus 7. Determine each of the following: a vector other than 5 minus 1 that is parallel to wx. When they say it is parallel to, it just means that they want a vector that is a scale factor of this. Right? What I mean by that is you could take any number, pick any number and multiply it. So let's say vector wx could be, not wx is 5 minus 1. I want something that's parallel to that, so you can take any number, it doesn't matter, right? You could say that, let's say 3. So you could say 3 by 5 minus 1 when this is a scale factor of this matrix or vector, column matrix. Right, so you're multiplying the vector outside by each term. So that's 3 by 5 is 15, and 3 by minus 1 is minus 3. So wx can also be 15 minus 3. Why? Because this is equal to 3 times your vector gives you 5 minus 1. The next thing they want is determine each of the following. What is wy? So wy, right? W is your starting point, and y is your ending point. So you're looking for a vector that has w and has y in it, right? And also you want a point in common. So those vectors must have something in common. So we know that the only one that starts with w is wx. Which one has y? X, y, and zy. But which one has something in common with it? The only one that has something in common is x, right? Z is not found in wx, so we cannot use zy. We can only use xy. So your starting point is w, right? The point in common is x, so wx plus xy would give you wy, right? You have to make sure that the numbers or the letters that are closest to your plus sign are the same. So you see the x's are the same, so wx plus xy. W here is your starting point, y is your ending point, and x's are your point in common. Okay, so now what is wx? Wx is 5 minus 1 plus what is xy? Minus 3, 7. You're adding this up to give you wy, right? So 5 plus minus 3 is 2, and minus 1 plus 7 is 6. So what will be wy? Wy, or vector wy, is going to be 2, 6. And that would be your answer. Let's look at number 2. Number 2 is xz. We're looking for something that has x and z in it, right? What has x and z in it? This one, well, wx, it has x, but it doesn't have z, so we cannot use this. We can use xy and zy. However, so what are the vectors we're going to be using? X, y, and zy. However, we want the ending point to be z, right? So instead of going in the direction zy, we will have to go in the opposite direction to form, if we're going in the opposite direction, it will form, this would be yz. So now when we add these two, that is x, y, plus your point in common is y, z, right? We will get x, z. Right? So x is your starting point. Y is your point in common. And z is your ending point. Right? So now that you know that, what is xy? Xy, let's just look. Xy is minus 3, 7. So we have x, y is minus 3, 7. Plus, we want the opposite of zy. So if we're going in the opposite direction, what we do is take zy. What is zy? Zy is 8 minus 7. So yz is going to be zy multiplied by negative 1. Right? Because we're going in the opposite direction, that's 8 minus 7 by negative 1. So that would be minus 1 by 8 is minus 8, and minus 1 by minus 7 is positive 7. So we know that yz is minus 8, 7. So your to find out what is xz, that's 3 minus 3 plus minus 8 is minus 11. 7 plus 7 is 14. So this here would be what xz is equal. So now we're looking at xy. We are going to look at what they gave us. Obviously, you cannot just take out what is x, what has x and what has y. Right. They don't want xy, they want the modulus of xy. Right? Now there's a formula for modulus. So the modulus, so if they say x, y, this is equal to the square root of, hold on, let me start this. This is xy, right? It gives you a vector AB, right? So once you have this, where xy is equals to AB, right? What is A and what is B? Xy is minus 3, 7. So if xy is AB and minus 3 minus 7, I'm just making sure, we can clearly see that A is equals to negative 3 and B is equals to 7. The formula for modulus is A squared plus B squared, and you're finding the square root. So that would be minus 3 squared plus 7 squared, and you find the square root for it. So 3 3s are 9. So the square root of 9 plus 49, right? That's equal to the square root of the square root of 58. You put this in your calculator and you will get 7.62 to 3 significant figures. And that would be your answer for this question. So again, if they ask you for, you see two straight lines like this, they're asking you for the modulus. You have to know what is the column vector for xy. We do know what is the column vector. It's minus 3, 7. The top one is A, the bottom one is B. So A is equals to minus 3, 7 is equal to B. Right? And you put it in this formula and you'll get the modulus of that vector. And that is how you would do this question.